All right, this is day 11, and we continue our study of linear programming, word problem edition. So we got two big word problems to do, and that's going to be what this lesson is about. First thing you do when you're solving any word problem is decide what your variables are going to be. When I'm talking variables, I like to look at the end of the problem to see what the variables are going to be. So, for example, let's see. I guess I should read over the whole problem first. Lisa makes banana bread and pumpkin bread to sell at a market. A loaf of banana bread requires 2 cups of flour and 2 eggs. A loaf of pumpkin bread requires 3 cups of flour and 1 egg. Lisa has 12 cups of flour and 8 eggs on hand. If Lisa makes $1.25 profit on each loaf of banana bread and 75 cents profit on pumpkin bread, find the amount of each kind of bread that she needs to sell to make the maximum profit. Okay, so this is a problem about loaves of bread. And in terms of what the variables need to be, I'm looking at the end. Okay, and it says find the amount, the amount of each kind of bread that she needs to make to maximize profit. But this tells me what the variables have to be. The variables have to represent the amount of each kind of bread. And in this case, we're talking about loaves of bread, or is it loaves? So we're talking about how many loaves of bread, okay? Loaves. Okay, anyway, so we have the two kinds. We got banana bread and pumpkin bread. So we'll use X for banana bread and Y for pumpkin bread, but let's be very specific. Let's let X be the, okay, I'll just put loaves of banana bread. Okay, and we'll let Y be loaves of pumpkin bread. All right, it's important to be as specific as you can with your variables. It will help you later. All right, in a linear programming problem, once you have the variables defined, the next thing you want to do is look for the constraints. Okay, remember a constraint is just a limitation. So we're looking for some kind of limitation. Now they were talking about how many cups of flour and how many eggs each one of them uses. So probably it's going to say something about a limit on the amount of flour and some sort of a limit on the number of eggs. And you will find that first constraint right here. Lisa has 12 cups of flour. Okay, that's all she's got for both kinds of bread. Banana bread, pumpkin bread, no matter what kind of bread she's making, she's got 12 cups of flour to use. So that is a constraint. That's a limitation. And you should label your constraints as you go along. So we have a flour constraint. Okay, so I'm just going to write flour. Okay, and underneath and next to the flour constraint, I'm going to write that first thing. Because we have a total of 12 cups, that's going to wind up going at the end of this constraint. So it's going to be like whatever else is happening, we have to use less than or equal to 12 cups of flour. Now, once we figure out that we're dealing with a flour constraint, scan through the problem. Look at our variables, loaves of banana bread, loaves of pumpkin bread. Somewhere in the problem it's going to say something about how many cups of flour for banana bread, how many cups of flour for pumpkin bread. And that will be what we use to build this inequality, for this constraint. So let's go back through. We're all about flour right now. Focus on flour. Okay, so a loaf of banana bread requires, here it comes, 2 cups of flour and 2 eggs, but we'll ignore that for now. A loaf of pumpkin bread requires 3 cups of flour. Okay, so did you catch that? All right, so we have a total of 12 cups of flour, and we're going to use 2 cups of flour for every loaf of banana bread. And we're going to use 3 cups of flour for every loaf of pumpkin bread. So this is where the rest of the inequality comes in. Since banana bread is x and pumpkin bread is y, it'll be 2x plus 3y. Okay? Again, that's 2 cups of flour for every loaf of banana bread, plus 3 cups of flour for every loaf of pumpkin bread, and that has to be less than or equal to 12 because that's our total. So here I've highlighted the flour constraint all in yellow. So one constraint down. Let's look for another constraint. All right, they kept saying flour and eggs. So probably there's going to be an egg constraint. So let's look for that. Let's do this constraint in blue. Okay, so. All right, Lisa has 12 cups of flour and 8 eggs on hand. So she's got 8 eggs. That is a constraint. She's only got 8 eggs, so she can make whatever she can make with 8 eggs. Alright, so as I go to write this constraint, which I'm going to write in red, I'm going to label this as an egg constraint. Okay, and she's got 8, so that means over here I'm going to have less than or equal to 8. So then it's a matter of, fine, how many eggs per banana loaf, x, and how many eggs for a pumpkin loaf, y. And let me go back to my highlighter and see what it says. Banana bread, 2 eggs. Pumpkin bread, 1 egg. Catch that? 2 eggs per banana bread loaf and 1 egg per pumpkin bread. So when I write that into my inequality, that's going to be, here's my 2 eggs per banana loaf plus my 1 egg per pumpkin loaf. I just don't need to put the 1 in front of it. I'll just put y for 1y. So these are my 2 main constraints, limitations. Now, I always like to throw in what I like to call a reality constraint. Okay? Reality. Reality dictates that, can I have negative loaves of bread? No. I can have 0 loaves, or 1, or 2, or 3, but there's no way to have negative loaves of bread, or really any object. You can't have negative objects. So that means that x is going to have to be greater than or equal to 0, and that means also that y is going to have to be greater than or equal to 0. So in addition to the flour constraints, the flour limitation and the egg limitation, there's a reality constraint. Can't have negative objects. All right, now it's time to graph all these. Or really, that was the hard part, is coming up with these inequalities accurately. If you have this done, the rest of it is fairly straightforward. It's what we've been doing. Now, down here where I say work, this is where we'll do calculations like rearranging these equations. So looking at our flour constraint in blue, 2x plus 3y is less than or equal to 12. I need to get y by itself, so I would subtract 2x from both sides. That'll leave me with 3y is less than or equal to negative 2x plus 12. Now I want to divide by 3. So I will do that like this. Okay, so that leaves me with y is less than or equal to negative 2/3 x plus 4. So here is one of my constraints that I'm going to graph. And I'm going to go ahead and graph it right now. Alright, it looks like I'll have enough space. Occasionally you have to count by something other than ones. So sometimes you have to count by 2s or 5s or 10s or even hundreds. But for now, let's see if we can get away with counting by ones. So 4. So 1, 2, 3, 4. That'd be right here. And now down to right 3. So down to right 3, down to right 3. Okay, I'm just going to draw this line. Okay. And let's make it blue for fun. Alright, because this is less than or equal to, I'm going to show just a tiny amount of shading on the bottom side of this line, just to remind me to stay below it. Alright, it's like grass. Now, because of the reality constraints, we might as well talk about that. The reality constraints, x equals 0, remember this would be a vertical line. So this is x equals 0 right here. And because we have to be greater than that, that just means we need to stay positive. Okay, so we have to stay on this side of the line. Is that a mosquito? Okay, so we have to stay on this side of the line. And this y equals 0 would be a horizontal line. So this is really the x-axis. And this greater than 0 business means we have to stay above it like this. So far we're inside this triangle. So whatever else we do is going to have to be inside this triangle. But let's go ahead and do the egg constraint. And I'll switch to red so everyone can follow easily. Alright? So this one's pretty straightforward. If I subtract 2x from both sides, then that's immediately going to give me y is less than or equal to negative 2x plus 8. So this is my egg constraint all ready to graph. So I'm going to start off at 8. So that was 4, 5, 6, 7, 8. And then I need to go down 2 over 1 from there. So down 2 over 1 like this. Okay, so I'm just going to go ahead and draw that line right here. And I'll make it red, and I'll make it a little bit bigger. Okay, so that is the egg constraint. Now, because it is, again, less than or equal to, we are going to shade a little bit below the line. So I'm just going to put that little bit of grass, a little bit of shading on the bottom side of the line to remind me that I have to stay on this side of the line. So now it becomes clear where the feasible region is. I have to be below the blue line and the red line at the same time, of course staying in the first quadrant. So that leaves me in this quadrilateral right here. And I'm going to use a little polygon to help me. So it's going to be like this, like this, like this. Oh, I missed. Alright, let me redo that. Okay, so here is the feasible region all shaded in. Obviously you would lightly shade that in with your pencil. Alright, I have to go do my lunch duty. But to be continued. You won't even notice I was gone. Okay, I'm back. Did you miss me? Now, we need the vertices of this feasible region. in order to maximize our objective function. All right, is that enough vocabulary for you? Let's see, what would be a good color for this? I think I'll go with green. No, let's do pink. Hot pink. Okay. So what had happened was we have a vertex here, 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 and here. So ordered pairs. That's 0, 0. That is 0, 4. This is 3, 2. And this is 4, 0. All right, those are the 4 vertices that we are going to use in our objective function. Now, we need to create the objective function. So let's look back. Now, all this business about objective function, you know, these words that you're throwing at me, vocabulary. Please understand that when we talk about an objective function, we're talking about it in this context. What is our objective? Okay? In other words, what is it that we are trying to accomplish? So, looking right here, we are trying to maximize profit. That's our objective. Money, profit. So, for this particular problem, our objective is going to be a profit objective. Okay? That's what we're trying to accomplish. We're trying to make that money. So when we write our objective function, I'm going to use P. In this case, we're looking for a profit function, a function for profit. And I will use P for profit. Okay? Now, just like when we did our egg constraint and our flour constraint, we scanned through the problem looking for any mention of banana and pumpkin. And you know, it was like, oh, 2 cups of flour for banana bread, 3 cups of flour for pumpkin bread. We're going to do the same thing with profit. We're going to scan through the problem, and we're listening for the words to say something about the profit. Profit from each kind of bread. Banana profit and pumpkin profit. So, when we find it, we're going to color it pink today. Okay, it's going to be some pink profit. So, and here, oh, whoops, I didn't have my highlighter tool. Messed up. Burton, you done messed up. Lisa makes $1.25 profit on each loaf of banana bread. Okay, $1.25 per banana bread. That's X. And then 75 cents profit on pumpkin bread. That's Y. So these are the 2 numbers that are going to go into my profit equation, my objective function. It'll be $1.25 per X, because that's banana bread, and plus 75 cents per Y, because that's pumpkin bread. So here we go. So like we said we would, we will do $1.25 per loaf of banana bread, plus 75 cents per loaf of pumpkin bread. So let me just double check that. $1.25 banana, 75 cents pumpkin. Okay, $1.25 X plus 75 cents Y. That's our total profit, adding up those 2 parts. So all that's left to do is to take these vertices one by one and substitute them in and see what the max and min is. So here we go. This part's easy. So we're going to do our 0, 0, and that'll be 1.25 times 0 plus 0.75 times 0, and of course that just gives you 0. You might be wondering why I used 2 parentheses here. I was also wondering the same thing. I guess neither one of us will ever know the answer to that. I like to just go clockwise so I don't skip anything. So 0, 4 is next. If I put that in, so that would be 1.25 times 0 plus 0.75 times 4. Okay, so that's going to be 3. All right, next I have this 3, 2 happening. All right, so it'll be 1.25 times 3 plus 0.75 times 2. Please understand, you could type in this entire expression into your TI-30 XS multiview. All right, so that is $5.25. And finally, we have our last point here. I can already see it's 4, 0. So that's going to make 1.25 times 4 plus 0.75 times 0. Okay, so it's basically just the 1.25 times 4 part. So that's 5. Okay, so hopefully you can see very easily that this is our maximum, and it came from this point right here, and of course that's our minimum up there, okay, which came from that one. So let's go ahead and write that down, speaking of max and min. Okay, just as part of your work, just go ahead and record that we had a max of 5.25. And that occurred at the point 3, 2. And then we had a min of 0, surprise, surprise, that occurred at 0, 0. So that should be in your work for your objective function. Now, this was a real world problem, all these words. So in the end, you have to get back into sentences. All right, so we have to translate this back into banana bread and pumpkin bread. So that's what the summary statement's all about. So remember, x, if we look back at our variables, one more time, x was the number of loaves of banana bread and y was loaves of pumpkin bread. So when we said we had this maximum profit of $5.25, and that occurred at 3, 2, the 3 tells us how many loaves of banana bread, because that's x. And that 2 tells us 2 loaves of pumpkin bread, because that was y. Now, when you write your summary statement, I want you to mention all 3 of these numbers, okay? Okay, and let's see. So person Lisa. So I'm going to say for a maximum profit of $5.25, Lisa should make three loaves of banana bread and 2 loaves of pumpkin bread. All right, boom. Now that is the most important part right there. That summary statement is the final answer. And that is what I'm going to look at first if I were grading this. I mean, this is what counts the most. So please take the time to write your sentences clearly and include all of your information. All right, so we're halfway there. It's one problem down. I'm going to do the second problem a little bit faster under the assumption that you learned something from the first problem. Is that a bad assumption? Maybe, but I hope not. So, más rápido, a little quicker. For the variables, that's where you start. I guess we should still read through the problem at least one time. Two manufacturing plants make the same kind of bicycle. Plant A uses 10 hours of general labor, 1 hour of machine time, and 5 hours of technical labor to make a bicycle. Plant B uses 1 hour of general labor, 3 hours of machine time, and 2 hours of technical labor to make a bicycle. For the two plants combined, the manufacturer can afford to use up to 4,000 hours of general labor, up to 1,500 hours of machine time, and up to 2,300 hours of technical labor per week. Plant A earns a profit of $70 per bicycle. Plant B earns a profit of $50 per bicycle. How many bicycles per week should the manufacturer make in each plant in order to maximize profit? All right, so right there at the end tells us the variables. How many bicycles per week in each plant? Okay, because that's the key here. There's plant A and there's plant B. So I'm going to use X to be the number of bikes at plant A. You know, just to abbreviate it a little bit, I'll just put bikes at plant A. And I'll use Y for the number of bikes made at plant B. Okay, so how many bikes? X and Y are the number of bikes. Now, the constraints are what you look for next. The constraints are limitations. All right, towards the end there, I started hearing about some limitations. It started right here. For the two plants combined, the manufacturer can afford to use up to 4,000 hours of general labor. That's a constraint. Can't go more than 4,000 hours of general labor. So that tells me that we are going to have a general labor constraint, okay, which I will do in blue. All right, so I'm just going to write this down. General labor. Please label your constraints. All right, general labor has to be less than or equal to 4,000 hours. So over here I'm going to write less than or equal to 4,000. Now, as I scan the rest of the problem, I'm sure it's going to say something about plant A does this many hours of general labor and plant B does this many hours of general labor. And that will be my X term and my Y term. All right? Since it's all general labor, I'm going to stick with my yellow highlighter. So let's see what it says. Plant A uses 10 hours of general labor. Okay, so that's 10x right there. And plant B uses 1 hour of general labor. So that's Y. So it's going to be 10x plus 1y, or just 10x plus y. And that'll give me the rest of my general labor constraint. Okay, so here we go. So 10x plus y. All right, I feel like moving this over a little bit. All right, and that has to be less than or equal to 4,000. All right, what are the other constraints? Let us switch over to blue. So right here we had our first constraint, up to 4,000 hours of general labor. Then we've got up to 1,500 hours of machine time. Machine time. So that's another constraint. I'm going to write that one in red. Okay, let's call it machine time. Okay. All right, so they said the total amount of machine time up to 1,500. So whatever else happens, the total machine time has got to be less than 1,500. So I'm going to scan the problem looking for how much machine time for plant A and how much machine time for plant B. Okay, it's all about machine time right now. So back to my blue highlighter. So plant A uses 1 hour of machine time. All right, skip, skip, skip. Plant B uses 3 hours of machine time. Okay, 1 hour of machine time, 3 hours of machine time. That's X plus 3Y, machine time. Okay, so back to my red marker. So X plus 3Y has to be less than or equal to 1,500. So that's two constraints. I think I heard a third because they kept saying general labor, machine time, and then technical labor. So that's going to be a third constraint. So let's see, there's our general labor, there's our machine time. So here comes our third constraint, which we will do in pink. All right, it says up to 2,300 hours of technical labor. Okay, 2,300 hours. So we're talking about technical labor now. You know what, I better do purple. Okay, so this will be my technical labor. All right, here comes a technical labor constraint. And whatever else happens, it's got to stay less than or equal to 2,300. So we scan through the problem looking for it to say how many hours of technical labor for plant A, how much technical labor plant B. And then that will be our inequality. So we were using pink for this. Okay, so let's see what it says. Plant A was 10 hours general labor, 1 hour of machine time, and 5 hours of technical labor. Skip, 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 skip. Plant B, 2 hours of technical labor. So 5 hours for plant A, 2 hours for plant B. That's 5x plus 2y. So that's going to be our third equation, for third inequality. So 5x plus 2y has to be less than or equal to 2,300. By the way, guys, see what I'm doing with this highlighter? Putting my constraints, all my general labor, one color. All my machine time, another color. All my technical labor, another color. Each constraint is a color. And then I make my my profit, you know, my objective function, a third color, a fourth color in this case. I highly recommend using highlighters. Okay, invest in some highlighters. Get yourself a yellow, a blue, a green, and a pink. And bring those with you to class and use those to mark up the problem to help you keep your thoughts organized. Anyway, so we need to rewrite each one of these equations in slope-intercept form. So I'm going to keep it color coordinated so it's obvious. So this first one, you know, I have this 10x plus y is less than or equal to 4,000. Subtracting 10x from both sides. Alright, is going to give me y is less than or equal to negative 10x plus 4,000. All right, so that is a giant y-intercept. Obviously, we cannot count by ones because it's 4,000. So keep that in mind. We're going to have to change the scale. Okay? We might wind up counting by 100. I don't know. We'll have to see. Okay, anyway, the second one, the red inequality. We've got x plus 3y is less than or equal to 1,500. Subtracting x from both sides, that gives me 3y is less than or equal to negative x plus 1,500. But then I have to divide both sides by 3. Like so. Don't forget that there's this invisible 1 here. So when I rewrite this equation, it's going to look like this. Y is less than or equal to negative 1/3 x plus 500. Okay, that's a lot less than 4,000. Okay, so this is my second constraint. Now the third constraint. Okay, let me just recopy it over here. So I've got 5x. Let me make it a little lower in case I have to number all this stuff. Okay, I've got 5x plus 2y is less than or equal to 2,300. So I need to subtract 5x from both sides. So that's going to give me 2y is less than or equal to negative 5x plus 2,300. And finally, I need to divide everything by 2. Divide by 2, divide by 2, divide by 2. So that's going to give me a final inequality of y is less than or equal to negative 5 over 2x plus 1,150. So this will be my third and final constraint. All right, so now we need to graph all three of these constraints. Oh, you know what? I forgot one thing. Back when I was listing the constraints, please let us not forget to write down our faithful reality constraints. I'm going to squeeze them in right here. You know what? I am not going to squeeze them in right there because I might have to put the numbers there. But I'm going to squeeze them in right here. Reality. Okay? Don't forget your reality constraints. X has to be greater than or equal to 0, and y has to be greater than or equal to 0. All right, that just puts us in the first quadrant, but please list that among your constraints. Do not forget your reality constraint. They count. All right, I actually have to go to eat lunch right now, but when I come back, we will graph these. We'll figure out what the scale needs to be so that 4,000 can fit. It might be that every square needs to be 20 or something like that, or 200. All right, so it's time to start graphing these inequalities. And our first one is a doozy with this 4,000. And as I tried to decide what I need to count by, I started by counting all these lines. And it seemed like, you know, I have 23, I forget, it's either 23 or 24. But that's about how many spaces I have. So it's a little more than 20. And I'm looking at the 4,000. So I'm asking myself, how many times does 20 go into 4,000? So, you know, if I divide 4,000 divided by 20, okay, that's 200. So that tells me that to reach 4,000, I need to count by about 200. So I'm going to try counting by 200. So this would be like 200, 400, 600, 800, 1,000. Okay? So that's like 1, 2, 3, 4, 5. Every 5 is 1,000. So 1, 2. So it's like 2, 4, 6, 8. This would be 2,000. All right, this would be 2,000, 200, 400, 600, 800, 3,000. 200, 400, 600, 800, 4,000. All right, and I'm going to do the same thing along this axis. It's going to be a little harder, but this is 200. All right, 400, 600, 800, 1,000. So this is 1,000, 200, 400, 600, 800, 2,000, 200, 400, 600, 800, 3,000, 3,000, 200, 400, 600, 800, 4,000. All right, I can put other numbers in as needed, but that gets us started off. So as I graph the first inequality, I start off at 4,000. Okay, so 4,000 is going to be way up here. So let me switch over to blue, because that's the color of that particular constraint. All right, so my first dot is going to be at 4,000. All right, now the slope is 10, negative 10 over 1. Okay, so it's like down 10 over 1. So let's get that started. So, all right, I'm gonna need a little space. So down 10, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1. Now, obviously I'm not really going down 10. I just went down 2,000 and over 200. Okay, but 2,000, negative 2, down 2,000 over 200. All right, that reduces to negative 10. So it's the same thing, same slope, so it's okay. It's okay that I'm going down 10 squares and over 1 square. All right, because it's the same slope. And you can do that as long as you use the same scale on the x-axis and the y-axis. Okay, anyway, I got to do that again. So down 10 over 1 again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1. So bam. So this is going to be my first line. Very steep, as you can see. All right, it's going to go all the way from 4,000 down here to 400. Okay, let's make it blue. Now this is less than or equal to, so I need to put a little bit of shading underneath. Okay, so I'm just going to put just enough grass on the below side of this line to remind me that I need to stay below the blue line for the feasible region. Alright, so already the feasible region has to be somewhere in this triangle. So whatever else I do, I'm trapped in here. Okay, so what's next? Now let's do the red equation. The red inequality, I should say. So the red inequality, starts at 500, and then it's going to go down 1 over 3 to the right. Okay, so starting at 500. So see, this is 400 and this is 600. So 500 will be halfway in between here. So here's 500. So I'm supposed to go down 1 over 3, that's slope. So I'm just going to do it in squares. So I'm going to go down 1 square and over 3 squares. Alright, down 1 square would put me here, in between. And if I go over 3, it'll be here. Alright, down 1 over 3. Okay, and then I kind of run out of space here. But let's go ahead and draw that line. See what we have so far. Okay. This is my red line. And I'm going to go ahead and shade just a little bit on the below side of the line. Okay, now I already knew that I had to be below the blue lines, which put me in this narrow area. Now I have to be below the red line as well. So that puts me in this area here. So I've got this really small feasible region so far. And yet there's one more constraint still to go. Okay, isn't there? We got this purple one. Okay, so we've got this one. It's 1,150 and then down 5 over 2. So 1,150. Okay, so I guess I need to switch to purple. Except I'm going to use this color. I like this a little better in terms of visibility. So 1,150. Okay, so this is 1,000. All right, and this would be 1,200. Okay, because it's going by 2s. So this would be 1,100 right here. So I guess this would be 1,150 would be right about here. All right, I'm really not liking how these are between the lines, but we just got to deal with it for right now. Okay, so now the slope of this is supposed to be down 5 and over 2. Okay, so I'm going to go down 5. So 1, 2, 3, 4, 5, and then over 2. So 1, 2. So that's going to be right about here. Okay, so when I draw this line, it's going to be like this. Okay. All right, this is about the ugliest system I've ever seen in my life. So this is once again a less than problem. Let me just double check. Yeah, so it's less than or equal to. So that means I'm going to shade underneath this as well. So a little bit of grass underneath like this. All right, this is getting so squished together that it's getting a little bit hard to see. Because it's so tiny, but I've committed to it, so let me just try to get you to see what's going on here. Let me switch to green. These are the vertices. Obviously I've got a vertex here at 0, 0. I've got another one here. Okay, let me record what I can see clearly. I've got 0, 0. Okay, fine. This is going to be a vertex, right? That one was 500. So that's going to be another vertex right there at 0, 500. All right, now these other vertices, okay? There's one here where the red line and the purple line meet. And I have sort of an estimate of what that is, but that's not going to be good enough. And then there's going to be another vertex here where the purple line and the blue line meet. And then there's going to be a fifth vertex here where the blue line touches the x-axis. That one I know. Okay, that one is going to be 400, 0. All right, so the bad news is because these lines are crossing like all between the lines and whatnot, we really need to solve the system of inequalities. All right, we need to solve this in order to find the points of intersection. Okay, so I know it's going to be painful, but I don't see any way around it. So this is what I mean. We need to take the purple line and the red line, and to see where they meet, we need to make a system of equations out of them. Okay, red and purple. Focus on those two. Okay, so red and purple. I better zoom out. And since I have all this space on my graph, I'm going to use it to do some work. Okay, so look at the red equation and the purple equation. Let me recopy them for a second. So the red equation is this one. X plus 3y is less than or equal to 1500. Okay, and then the purple equation is 5x plus 2y, okay, is less than or equal to, you know what, let's just do equals because we're trying to see where the lines meet, so we don't need to worry about inequalities right now. So 2,300, and this is also equals. So what we need to do is do substitution or elimination to find out where these two lines actually meet. I propose elimination method because of the way they're all stacked up. So this is positive 5x, for example. If I could make this into a negative 5x, I would be golden. So I'm going to multiply the top equation by negative 5. That's going to give me negative 5x minus 15y is equal to, let's see, I better do this in my calculator, negative 5 times 1,500. So that's going to be negative 7,500. The bottom equation didn't change, so I'm just going to copy that down. So 5x plus 2y is equal to 2,300. If I put these together, these are going to cancel out. So that's going to give me negative 13y is equal to, and if I do negative 7,500 plus 2,300, that's going to give me negative 5,200. So if I turn around and divide by 13, well, negative 13 on both sides. Let's see what I get. Get y equals 400. Okay, that means the y value of this point here is 400. Remember, we're doing the red and the purple. That means we're trying to see where the red line and the purple line meet. So the y value is 400, which looks about right. Now let's do the x value. For the x value, we can just take this, substitute it back into one of these original equations. I'm going to use the red equation. So if I take this x plus 3y and put in 400, and that's supposed to equal 1,500. Okay, so that's x plus 1,200, subtract. So that's going to give me x equals 300. Okay, so that tells me the coordinates of this point. Let me zoom back in so you can see what we just discovered. Alright, so that tells me that this point of intersection right here, okay, where the purple and the red met, was 300, 400. Alright, and that looks about right, because 300 would be right here in between, and then 400 is right on the line. So it looks about right. Okay, now we need to find the intersection point of the purple and the blue. So we need to do the same thing one more time. Okay, but now this time we're doing the purple and the blue. Alright, so let me draw a line. I'm going to try to squeeze this in. So the blue equation, okay, is 10x plus y is less than or equal to 4,000. Alright, so we're doing the blue. We're finding where the blue line and the purple line meet. Alright, so here's the blue equation, and here comes the purple equation. Well, I just used the purple equation a second ago, so I can just copy it from here. So that's going to be 5x plus 2y is less than or equal to 2,300. So let's put these guys together. Alright, I feel like I should use a different color now. I'll try this one. It doesn't matter which one of these I want to eliminate. Okay, it really doesn't matter. I'll just eliminate the x's really only because they're in front. So if I multiply this by -2, that will make this into a -10, which will cancel out the +10. So the top equation, I'm just going to keep it how it is. 10x plus y is less than or equal to 4,000. But the bottom equation, that's going to be -10x minus 4y is less than or equal to, alright, so I'm doing 2,300 times -2, and I'm getting -4,600. Alright, so putting these together, that's going to give me -3y is less than or equal to, and this is going to give me -600. Now we have to divide everything by -3. Okay, so that's going to give me y is less than or equal to positive, wait, oh, you know what, I meant to be using equal signs this whole time. I was about to talk about reversing inequality and all that. We're just finding where these meet, so all these inequalities don't matter. Let's just do the equations. Equals, 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 equals. Okay, so this is going to, y equals positive 200. Alright, so we have y. Now we need to find x. So I could use either one of these equations. I'll use the purple one. So say if I do 5x plus 2y, so here I'm going to go ahead and put my 200, because that's y, equals 2,300. So that's going to be 5x plus 400 is equal to 2,300. So that's going to give me 1,000. Oh, I guess I should show it. I am subtracting 400 from both sides. All right, so that's going to give me 1,900. So I'll have 5x equals 1,900. Then of course I need to divide both sides by 5. And let's see what that gives me. Okay, that's going to give me x is equal to 380. Okay, so 380 comma 200. That is where the blue line and the purple line meet. 380 comma 200. So let's put that on the graph. So this, I'm talking about, this is this point right here. Okay, and I guess we can just point to it. Maybe I'll put it closer. So 380 comma 200. Okay, now we have all 5 points. I've got the 3 green ones that were easy to see right from the beginning, but I had to solve a system to find out where the red and the purple met. I had to do elimination method with the red and the purple. All right, and it came up with 300 comma 400. To see where the purple and the blue met, I had to do the elimination method with the purple and the blue. And I came up with 380 comma 200. All right, that was harder. It really doesn't get any harder than this. And but sometimes this is what is necessary. So I would love to tell you that, oh, it won't be on the test. The ones on the test won't be this hard. But I cannot promise you that. So it all comes together. This is advanced math, advanced algebra. So maybe you're starting to see why they call it advanced. Okay, the rest is easy, but we're probably still scared from the hard part that we just did. So let's take these vertices one at a time. Oh, you know what? We need our objective function next. All right, so let's go back into the problem and find our objective. As often is the case, our objective is to maximize profit. So I can show you that the profit information is right here. Plant A earns a profit of $70 per bicycle, and Plant B earns a profit of $50 per bicycle. So remember, Plant A is A, Plant B is Y. So that's 70x. I mean, Plant A is X, Plant B is Y. Is that what I said? So that's 70x plus 50y is our profit function. Okay, so what you do is, for the objective function, label it. This is a profit function, so we will call it P. Okay, so looking one more time at the sentence, it was $70 at Plant A and $50 at Plant B, so that's 70x plus 50y. So profit equals $70 from Plant A plus $50 per bike from Plant B. So that is the function into which we will substitute all of our vertices. Okay, now our vertices are, I'm just going to make my list first. Our vertices are 0, 0, 0, 500, 300, 400, and okay, and then there's 380, 200, and 400, 0. Okay, so this is a complicated problem. Not only did we have to solve these systems, all right, to find these little intersection points, but whereas usually there are only 4 vertices or less, this time there were 5. All right, so let's zoom in as we actually do the math. All right, apologize for the sloppiness. Maybe I'll clean it up a bit. All right, so these are the 5 vertices. As I put them in, for this one is always the easy one. Okay, because that just gives me 0. When I put in this one, got 70 times 0 plus 50 times 500. All right. 50 times 500 is 25,000. Okay, now the next one, 70 times 300 plus 50 times 400 that's 41,000. Okay, so that is the one that's winning so far. But let's go to the next one. 70 times 380 plus 50 times 200. Yeah, 380. I knew I was messing that up. Okay, so that's 36,600. Okay, so the 41,000 is winning so far. All right, and last but not least, 70 times 400 plus 50 times 0. Okay, 7 times 4 is 28. So, you know, it's going to be 28,000. Okay, these are the results. The main thing we care about is that maximum value. Okay, where you can see that the maximum value is 41,000. And that occurred at this point, all right, 300, 400. Okay, so note, we had a max, all right, this is a maximum profit of 41,000, all right, which occurred at 300, 400. All right, not that we need it for this particular problem, but the minimum was 0, which occurred at 0, 0. So it's time to take that and put it into words. So we're going to say for a maximum profit of $41,000. Maybe I should type this. My writing can be a little sloppy sometimes. Okay, so for maximum profit of $41,000, they should make 300 bikes at plant A and 400 bikes at plant B. Okay, man, that was the roughest problem I've ever done. Okay, so if you're feeling like that was a rough problem, I'm with you, man. That was a rough problem. However, you actually need to be prepared to do a problem like that. All right, we're just gonna have to suck it up and be prepared to do it. Okay, practice makes perfect. So we'll just do more problems. We'll have another one of these for homework tomorrow, and maybe we'll do one in class. But for now, thank goodness this is over. I will see you on the next video. Come in for help if you are actually in my class.